In this case, you've been asked for at what rate is x decreasing, so dx dt is what you want, and you've been given d theta dt to be 2 radians per minute. So that means I need something that is relating the opposite side of a triangle with the angle and the hypotenuse, and the hypotenuse is always 5 because it's labeled as a number and not set in an instant. Whereas the instant when x equals 4 means eventually we'll be able to plug 4 in for x, but not right away because it's not always 4 units. So sine of theta relates opposite over hypotenuse. The opposite is x, and the hypotenuse is always 5, so we'll make that a constant. Now, to introduce the rates I need, I will differentiate with respect to time. The derivative of sine is cosine theta, d theta dt. And this is equal to 1/5. The derivative of x is just dx dt. Now we take stock of everything that we have and are given and we need. We need this. We've been given that this is 2, and it's decreasing, so this is a negative 2. Cosine of theta is going to be adjacent over hypotenuse. And so now we will use the information when the instant x is 4. But when the instant x is 4, the adjacent is 3, so that we have a 3, 4, 5 triangle. And so a over h is equal to 3 over 5. So plugging everything in, we have 3/5, that's the cosine of theta part, times d theta dt, which is negative 2, is equal to 1/5 dx dt. I will multiply everything by 5 over 1, the reciprocal of 1/5, and I'll get dx dt equals 5 over 1 times 3 over 5 times negative 2. The 5's cancel, so I'm looking at negative 6 radians per minute. Or I'm sorry, I'm not given any units, so just negative 6. But because we are told that x is decreasing, that's the negative portion, so I shouldn't expect a negative to show up in my answer because I know that we're decreasing, so I'm just looking for the 6.